In this titration, we'll be looking at how to calculate relative atomic mass and also relative molecular mass using titration methods. In this question, we have the question says A is a solution of tetrasulfur acid containing 3.92 grams of the acid dm cube. B was prepared by dissolving 3.6 grams of carbonate. The carbonate is X substitute 2 CO substitute 3 in 1 dm cube of solution. Now, after the experiment, adding acid to the burette, titrating using 20 or 25 cm cube of the pipette, we arrive at this. Say that from your results and information given, calculate the concentration of tetrasulfur acid in mole per dm cube, and the second one is concentration of the carbonate in mole per dm cube. The third one is relative atomic mass of the carbonate, and the final one is the third one is relative molecular mass of the carbonate, and the fourth one is the relative atomic mass of X. Now this is the equation of the reaction, equation for the reaction, and then what we have here is the tabulated reading of the titration. In the titration, we use 25 cm cube pipette. The volume of the pipette is 25 cm cube. So in this case, this is what we have here. And to take care of the first question, they said that calculate the concentration of the tetrasulfur acid in mole per dm cube. We have here, we were given the mass of the acid, and also from here we can get the molar mass of the acid, which we can get by everything here. We have it to be this because this is 132 and then 4 brackets 16. Let me just make it a bit easier. (32) So when you sum up all this, you notice that what you have is this. So this is the relative, that is the molar mass. So the molar mass or relative atomic mass of that. So with this now, having that we have a 3.9 grams of the acid dissolved in the solution, that means the mole concentration based on this we have here will then be, the mole concentration will be mole is equal to 3.92 grams over what 98. That will give us 0.04 mole per dm cube. 0.04 mole per dm cube. That is what we have. And the next one said concentration of the carbonate in mole per dm cube. In this case, since we are looking for that, we can now use our relation, which is from our chemical equation. We find out that this is equal to 1, this is also equal to 1, and from here we can get our average volume. The average volume of the of the acid used, the average volume, we can go for these two that is closer to each other, which we have the result, the values there happens to be 21.3, 21.3. Then the volume of A is equal to 21.3, that is average volume of A will be 21.3 plus 21.3 all over 2. That will give us 21.3 altogether, cm cube. So that is what we have here by using this tool that we're looking at here. And then this is what we have. That means for the A now, concentration is 0.04. For the volume of A used is equal to 21.3, and for volume of B used is 25.25 cm cube mole per dm cube, and then concentration is what we are looking for. So using this our ratio, like we stated there already, we have that will be A is to, from their ratio, 1:1. So the next thing we are going to do here is, we have already gotten the moles. So mole concentration of the acid already. So what we do here now is to substitute for all the values that we have here. A is 25.3 times, that's the volume, times concentration, which is all over, this is for the volume, this for the concentration, and then this other one we don't have it, times 25 equal to 1:1. So when we cross multiply, what we have is CB is equal to 21.3 all over 25. So dividing this through, what we have here will be 0.034 approximately mole per dm cube. That is what we have for the concentration of the B. The B is this 0.034 mole per dm cube. So the next one we're going to do here is, we'll come over to the second question. The second question, we have done it. The next one is the third question we are going to solve now. In the third question, it said that we should calculate the relative molecular mass of the carbonate. Then from our equation, we know that 0.034 moles of S carbonate contain 3.6 grams. Now 1 mole will then be, that will give us what we're going to get here will be, that will give us 105.9. That is 105.9. That is what we have. So now we have the relative molecular mass of the carbonate. Then the next question, they say that calculate the relative atomic mass of X. Relative atomic mass of X. To calculate the relative atomic mass of X, what we do here is, we know that is equal to 0105.9. And from here, you notice that 2 brackets x, and then the next one plus carbon, which is 12, carbon, which is 12, plus 3, 16. 3 brackets 16 will give us, so 3 times 16 will give us 48, and then 12 plus 2x. When we add up these two, we'll have 60 equal to 105.6. So is that what the next thing is, that taking 6 over, carrying it over, we have minus 60. So when we subtract, if we subtract this from that, we have 45.9 equal to 2x, equal to 2x. Then x will then be over 2. That will give us 2.95, or approximately we have 23. All right, thank you so much for being part of this. I would like to, see your comments, like and share. Thank you.